We know that the water enters the tank with circular base at 10 cubic feet per minute, and if water level rises by 1 feet per minute, we have to determine the corresponding radius. So first we have to identify the shape of the tank. As it is given that the tank is having a circular base, we know that the tank has to be a right circular cylinder because only a right circular cylinder has a circular base. So that's why I drawn the shape of the water tank as like a right circular cylinder with radius r and height as h. And let's convert the given information to mathematical symbols. That is, we are going to use the derivatives to convert this information into derivatives form. So this information is water enters the tank, which means the volume of the water keeps increasing. So basically, they have given the rate of change of volume, so which can be written as dV by dt. So this is given as 10 cubic feet per minute. So I can put this as 10 feet cube per minute. And we are also given that the water level raises by 1 feet per minute. So using derivatives, if we convert this, we can write down this as water level raises, which means visually we can understand that the height is increasing. So I can represent this information as dH over dt. So this is equivalent to 1 feet per minute. At this point of time, we have to determine the radius. So first, let's use the formula for right circular cylinder. The volume of a right circular cylinder is given as pi r squared h. Now let's find the derivatives on both sides. So if you find the derivative of v with respect to time, we have dv by dt here and pi. I'm going to keep the radius as constant because radius is not increasing in this question. So only the height is increasing. So I'm going to keep this pi r squared as constant. And if I differentiate only the h, I'll be getting dh over dt. So now I have formed an equation where I can plug in the given information to determine the corresponding radius. So I'm going to plug in dv by dt as 10 and dh by dt as 1 without the units. So when I do that, so here I can plug 10. So this will become pi r squared times of dh by dt is 1. I'm not using the units, I'm just plugging only the numericals. So now I have to solve for radius. So this is equal to 10 equals pi r squared. Now I can divide both sides by pi. So this implies 10 over pi equal to r squared. I can take a square root on both sides so that I can solve for radius. So I take the square root on both sides. So this will become square root of 10 over pi equal to radius. So therefore the corresponding radius when the water level increases by 1 feet per minute is square root of 10 over pi.